Okay, continue to the chapter 3.3 conditional distribution. Okay, this is also my homework today, but I don't have some clear mind, so it's also a good time to quick review and have some deeper understanding. The problem on me nowadays is just that I think I can understand the process, but I think I understand the system well, but I just for some specific field topic and tools when I want to use it, I just I doesn't familiar with I don't familiar I doesn't very familiar. Oh, this is just Chinese logic to represent. Uh, I doesn't uh, familiar with the oh I know why just why I think my expression is very uncomfortable because I just use the Chinese logic to express, and when I use the Chinese logic, I also think that it's very difficult for me to express, and I think it's very bad to express in Chinese logic. I don't feel well when I express. So how to express in English logic? And I now I don't know that I best try my best. Okay. Continue. Oh, there's some problem, so I think I should spend more time on the materials and slide and spend more time on thinking and on the definition and concept. There's uh, last chapter we have talked about the the independence, and now the inverse viewpoint is that now we begin the condition. What is the condition? So there are two topics that discrete and connect. Because one thing, if XNY discrete random, then it's never destroy the conditional probability function of x given that y equals to y. By this method, what is the meaning of this? Because it's, if they are not, they are dependent on each other, so we can just use. Oh, I think they are similar because the one says that they have no relationship, and now they have some relationship. So I think I need to do some uh, mathematical work so that I can represent the information of between their relationship. So here we go, and these are the very easy things. So why we do this? Why we do this? Because we just use the conditional probability function. That is to say, we just use it. How could we induce this formula? Yeah, exactly. Oh, marginal distribution rule. Marginal distribution rule. I don't think very easy to understand this point, but so that is just something. This is another thing that is a little bit difficult. That 1x0, 1 and this what is, so we can just to display all possible things that to say we can do some computational represents all of them very easy because these are just very simple relationship between x1 and y. So we can just emute and very easy to display all of the possible, all of the results. And this is just some discrete time. And a store have certain goal x be the number we enter. Oh, this is another typical example. And the Poisson distribution. That is, x is the property of the event that is p if certain are independent. What is if customer independent, then the number of customers who purchase the certain goods. The number of customers who let here go. Suppose that y is the number of who are executed, so execute m equals. This is just the Poisson, or I just get this formula. Poisson distribution execute m, and so that the number of customers entering is m. The condition is binary, binomial distribution. That is to say, using total distribution formula. And that is to say, it's a little bit difficult for me to induce all the mathematical operations, but it's very easy to understand. Nail it. Continuous case means that if x1 on joint probability density function and the conditional property y. And I think this is just the same as the discrete, because this is just the continuous case. Similarly, the conditional probability density function of y given at equal to x is given by what? Fy. Well, these are just the similar expression. That is to say, the one key point is that how to define the range of the random variable. And if x and y have the joint, however, they are different. Continuous case means that, in fact, for each fixed value of y such that fy bigger than 0, the function y will be permanently for each value of y such that y that will be a PDF over the real line since outside that and the necessarily for each fixed value such as y that the function line is also fit over a real value over a real value. The meaning is just that. So how to deduce it? What is the fxy equals to y try to do it? very easy to induce this formula. We just use the meaning of the definition and the induce of the dependent variable, the best possible formula. Probability, not I mix up about the probability and possible. And so, nice try. So when there is a value of this, it must be it also be a uniform distribution. And this is also a remark. Conditional is not the result of condition on set of the actually is a limit. The conditional event is possible if the marginal for density function y is part. Okay, little bit tricky, mixed up, and fxy limit y more than x. Continuous case. Okay, please remember that this is just determine the x y and y x. The joint is keeping a constancy, so it must be this, and we can learn about that. K is equal to 2, I think. So this equals to what? Okay, Fy. We can easily get the result. Not very difficult. Just very basic operation. And communication. 1, 2 we get 0 smaller than y no. La 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 la. Now some key point is that we should remember what is the range of y. Both of them are uniform distribution that consider the continuous case. These are just some typical homework. Okay. Now I think it's very easy. Why? Before I look at this, the solution, I think is a little bit difficult because first I don't remember well about what is this formula, how to deal with it, with the definition. Okay. The second one is that when I find my best to understand the meaning, I think I got the meaning, but I can't make a combination to solve it. And I think I focus. Night is just night. Now is just present. Present is the present, and it's a gift, and it is the perfect. Okay, this is just some second thing. Define which and determine the value of the also determine. Okay, BNC are a little bit messy. Fx equals to something easily for y is so there are two range we should do two conditional. What we should do is easy, but what is the last x equals to, for instance? We just should use this. Okay. Some tricky thing that this is just use the definition of the. Oh, I think it's just so easy, tricky. A little tricky. The B is problem. The question B is the definition of the independent formula, and the question C just use the integral of the density function. Okay, this is just some other examples that it say when given x equals the product of y equals to fy times equals to fy times the speed of continuous. Not very interesting to do this mathematical works. This great continuous, I think. Oh, I just know how to do, but I don't think I have nailed it. Thank you very much.